Oh, again, good afternoon sa inyo. And just tell me if merong magre-report in our group, but so far wala pa namang nag-commit. So we will just proceed with our presentation, which is about the statistical methods in data analysis. So let's have a look on, this is for general na lahat ha. So let's just watch.
Some statistical methods or techniques that you may apply in data analysis of your research. In doing this, you have to go back in your statement of the problem or the objectives of your study, because this will serve as your basis on what statistical techniques you are going to use in analyzing the data associated in each statement. So first, let's identify what is a statistical analysis. So a statistical analysis involves analyzing collected data with the aid of statistical tool to answer the research problem. Thus, this gives meaning to the data collected. This is why you have to use your research problem or your statement of the problem as basis in selecting appropriate statistical techniques in analyzing the data that you wish to obtain based on each statement of the problem of your research study. So, here are the following basic research statistical designs that you may employ in your research. We have the descriptive statistics, and actually this is common as it describes the relationship between the variables, and it provides a summary of data in the form of mean, median, and mode. And also, you can describe the data under descriptive statistics with the use of percentage frequency distribution. Another is we have the inferential statistics. So on this, the data are analyzed from a sample to make inferences in the larger collection of the population. The purpose of this is to answer or test the hypothesis. If your research attempts to test the hypothesis, you may use inferential statistic design. So here we have the percentage frequency distribution. This is under the descriptive statistics because you only summarize here the frequency and percentage of the data, particularly the categorical data. Because when we say categorical data, these are the data that you categorize this according to their criterion or according to their characteristics. For example, sex. So we categorize sex into two. We have the male and female. So here, based in our data collected, we have 120 male respondents or 60% of the total respondents, and we have 80 female respondents or 40% of the total respondents. So actually, the frequency or percentage frequency distribution can be commonly done in chart or table, as you can see on these two figures. So you can choose the pie chart in order to see the figure about the portion of each categorical data, or you can use the table to summarize the frequency and the percentage distribution of each categorical data. So we have also common statistical techniques here, and we have the measure of central tendency. So in the measure of central tendency, the data describes the average of the data using mean, median, or mode. So these are familiar. So here, you have to attest the center or the average. It can be through the mean, no, or the average, or the median. So in median, this is very good or very applicable, especially if you want to address the outliers or the data that is from far away from the center or from the common data, and or mode, or the usual um, data that you observe, no, from the observations. So that is for the measure of central tendency. So another, in the higher statistical techniques, we have parametric test. So actually, in parametric tests, this test assumes that the data are on quantitative numerical scale with a normal distribution of the underlying population. Actually, in the parametric test, the data here are in continuous, or this involves continuous variables. So what are those continuous variables? For example, we have age, no, because that is continuous variable. You can have from age 1 until age 100, or and so on. And also income, that is also a continuous variables or other quantitative or numerical scale. So under the parametric test, we have the t-test. This is really common. And this t-test is used to test the null hypothesis, in which to determine if there is a no difference, especially the null hypothesis, no? There is no difference between the means of the two groups. Unfortunately, the disadvantage of t-test is that it cannot be used for comparison of 3 or more groups. So the focus here is very applicable only for the 2 groups. But in order to address or in order to compare 3 or more groups using this parametric test, we can use the analysis of variance, or ANOVA. So in ANOVA, this is used to test if there is any significant difference between the means of 2 or more groups. So that is for the analysis of variance, or the ANOVA. Another, we have the non-parametric tests. So why is it non-parametric test? Because the data that is being analyzed on this technique or on this test are not continuous data. Unlike with the parametric test, they used to analyze continuous data. Here, it used to analyze ordinal and categorical data, which are set in order for ordinal and category or in scale form for categorical data. So, the common example of this technique are the Mann-Whitney test. First is the Mann-Whitney test. So, in the Mann-Whitney test, it is used to test the null hypothesis by which the two samples have the same median, or alternatively, whether observations in one sample tend to be larger than observations in other. So that is for the Mann-Whitney test. Whitney test. So actually, this is more on the two samples, or this is actually the version of the t-test, but on this, it focuses on the ordinal or the categorical data. Kruskal-Wallis Test. So, in Kruskal-Wallis Test, this is a non-parametric test to analyze the variance. So, but this is not in a continuous data, but it is in ordinal data. So, the data here are in order. So, it analyzes if there is any difference in the median values of 3 or more independent samples. So the data values are ranked in an increasing order because it involves ordinal data, and the rank sums calculated followed by calculation of the test statistic. Actually, you can have this, or you can get the result of this Kruskal-Wallis test using the statistical tool. Not just only on this test, but all of the statistical techniques can be obtained using a statistical tool, and you have to make sure that you have a wide knowledge or the mastery in running those statistical tool and performing this series of statistical tests or techniques. And another we have the Friedman test. So this is a non-parametric test for testing the difference between related samples. The Friedman test is actually an alternative for repeated measures ANOVAs, which is used when the same parameter has been measured under different conditions on the same subject. So that is for the Friedman test. And other non-parametric technique is we have the Spearman rank test. Actually, the Spearman rank test is the same with the correlation analysis, by which you test the strength of a link between the two sets of the categorical data variables. This is actually applicable if your data are more on Likert scale and you want to examine the link between the two variables by which their data sets are in Likert, or by which these two variables are in categorical data or in Likert scale. For example, we have the level of awareness and the practices. So for example, so you obtain the data of these two variables. We have the level of awareness, which is your independent variable, and the practices or level of practices, which is your dependent variable. And you want to test the strength, the link between these two variables. And these variables, you obtain this using a Likert scale, or thus the data for these variables are in categorical data. So you may apply Spearman rank test in testing the strength or the link or the relationship, significant relationship, or the relationship, positive or negative, between the level of awareness, which is a categorical data and independent, and the practices, which is your dependent variable and has the categorical data. So that is when we apply the Spearman rank test. So another common statistical techniques here is we have the correlation statistics, and this is very common. So actually, this is a statistical technique that can show whether and how strongly pairs of variables are related. The same with the Spearman rank test, but the difference is that in the Spearman rank test, it focuses on the categorical data. Here, under the correlation statistics, it shows how strong relationship of the variables, no? Or how strongly pairs of variables are related. And under this is we have the Pearson's correlation. So in the Pearson's correlation, this tests the statistical relationship or association between two continuous variables. Take note, it's not categorical data variables, but two continuous variables. So for example, we have age, but sometimes also age can be categorical data. It depends on how you get the data. So if there is no limit or there is no category in determining the age, then you can use age as your continuous variables. For example, 16, 17, 18, and so on. If you obtain the age using the categorical data, like for example, old, young, that is categorical data, then you may use the Spearman rank test. So here, it is applicable for the continuous variable. And lastly, we have the regression analysis. Actually, the regression analysis is a powerful statistical method that allows you to examine the relationship between two or more variables of interest. So, this examines the influence or effect of one or more variables on a independent or a dependent variable. So, this examines the influence or effect of one or more independent variables on a dependent variable. So, if your study wants to assess the effect of this independent variable on dependent variable, or if you want to examine the influence of this variable to another variable, or if you want to assess the factors influencing this dependent variable, then regression analysis is the best tool that, or the best technique that you may use. So actually there are various types of regression analysis depending on the data and on the statement of the problem that you want to assess. So actually, if you are going to use the OLS or the ordinary least square regression, then you have to obtain data more than 30, and also it depends on how many parameters that you are going to use, because the degree of freedom is also related on that. But there are also regression analysis or other types of regression that can use to address data which are less than 30, and especially this data are in time series. So you can use the ARIMA for the univariate analysis, or you may use the VAR or the vector autoregressive for the multivariate. And here on this video, I'm just only focusing on the overview only, on what statistical techniques you may employ in your research. So these are basic only. So there are other types. We have also factorial analysis, we have also structural equation modeling. We can apply also those. And this video is limited lang only in the regression analysis and those other statistical techniques that have mentioned. But in order to know this more, I will show you the 5 key assumptions under this analysis. So if you wish to use this analysis or this type of statistical technique, you have to ensure that your model underlies on these 5 key assumptions. So you have to make sure that the relationship of your independent and dependent variable is linear. So the linearity assumption can be tested with scatter plots. And another assumption is that we have this multivariate normality. This means that your data should be in normal distribution, and you have to address also the outliers. And also this can be best checked with a histogram or the QQ plot, so to attest if this variable or certain variable is positively skewed or negatively skewed, then we will decide if we need to transform this variable into log form or into exponential form. And actually, the normality can be checked with a goodness of fit test. There are various of goodness of fit tests that can check the normality of your data. Another is we have the no or little multicollinearity. So actually, multicollinearity exists, and this is a phenomenon by which one predictor variable in a regression model can be linearly predicted from the others with a substantial degree of accuracy. So if your model or the multicollinearity issue of that model is very serious, then there is a there is a possible implication on the in estimating the coefficient of that regression model, and may change erratically in response to small changes in the model or the data. And actually, the multicollinearity does not reduce the predictive power or the reliability of the model as a whole. But at least within the sample data set, it only affects the calculation with regards to the individual predictors. And actually, this assumption can be best tested with variance inflation factor and correlation matrix. In multicollinearity kasi, it shows this, for example, this variable is highly correlated with this other independent variable. So, for example, you have the population as your variable, and you have also the another variable, independent variable, which is population growth.
I
So, I
think
think the
the
population and
population growth
population
is
growth
somehow
are highly
related.
correlated.
On
Highly
this,
related,
you
of
have
course.
to omit
So on this,
either
you have to
the
omit
population variable
maybe
or the
the
population growth
population
in
variable
order to
from the
address the
model,
multicollinearity
or
issue.
the we have the no autocorrelation. So in when we say autocorrelation, it occurs when the residuals are not independent from each other.
In testing the autocorrelation, it can be best tested with Durbin-Watson test, which it tests the null hypothesis that the residuals are not linearly autocorrelated.
So when we say autocorrelated, so the correlation between the elements of a series of data or these variables, no, are almost the same, no, and others from the series separated from them by a given interval. And lastly, we have the assumption of homoscedastic. So, when we say homoscedastic, it is equal variance. In measuring the homoscedastic, actually, scatter plot is good way to check whether the data are homoscedastic or equal across the regression line. And actually, it is somehow related with the normality of the distribution of your data variables in a certain plot. So this can be best tested with Bruch-Pagan test. This is actually a diagnostic test for testing the homoscedasticity, and the IM test. So actually in homoscedasticity, it describes a situation in which the error term or the disturbance of your model, or the random disturbance in the relationship between the independent variables and dependent variable, is the same across all values of the independent variables. So in order for the model to be homoscedastic, we have to address the violation of homoscedasticity, and that is heteroskedasticity. So this happens, the heteroskedasticity is actually different from homoscedasticity, ha. The heteroskedasticity is present when the size of the error term differs across values of an independent variable. So actually, there is an impact of violating the assumption of this homoscedasticity, because actually it is the homoscedasticity matters of degree. So you need, no, in order for the model to be good or under the goodness and fit or to improve, you have to follow this assumption. So thus so that is for the regression analysis. This is only an overview. So under these assumptions. So what are the steps in conducting statistical analysis? So you have to follow these steps. And these steps are you need to consider in conducting a statistical analysis. First is you need to identify your research problem, because your research problem will serve as the basis on what statistical technique you are going to use in answering that problem and in analyzing your data to come up with a solution or with an answer. And also you describe the nature of the data to be analyzed based on your research problem. So you have to describe if this data is categorical, ordinal, or continuous variable. Then you may apply the applicable techniques or statistical techniques in describing or in analyzing the data. Then you use your research framework, especially the empirical model or the equation, to summarize understanding of how the data relates with each other. And also, you have to prove or disprove the validity of the model using your hypothesis, especially if you deal with inferential statistics or if you are going to test your hypothesis. And employ applicable statistical techniques to run scenarios that will help you guide future actions and can answer your research problem. So that is why in each statement of the problem, you really have to identify what statistical technique is applicable in drawing an analysis of data from answering that statement of the problem. So, of course, in running or in performing your statistical techniques that you are going to employ, you need this following statistical tools. So, you may have this SPSS. You may download a trial for free from this website. If you have money to purchase data, actually, among this two, I prefer Stata because it is user-friendly. But, of course, you have to determine or you have to have enough understanding about the commands of Stata. Then, you may use the Megastat, but there are, especially in analyzing the t-test or ANOVA, or you can do also correlation analysis using the Megastat as long as you know the formulas or on how you input the formulas in the Excel or in the Megastat. So actually in the Excel, you need to employ this Megastat or you need to gauge this Megastat to your Excel. And we have the R. If you know the codes, if you know how to use the R, then you may use R in estimating your data. Actually, you can do regression analysis in R, factorial analysis. You may use the principal component analysis. There are different analysis in analyzing your research, and those that I presented a while ago, those are the basics. Those are the common statistical techniques. And there are lots of statistical techniques that you may use, no, depending on the research problem of your paper. So this is all for today's video about the statistical methods in data analysis. And I hope you learned something on this video and be able to understand what are the statistical methods applicable to your study. And thank you for listening.
Okay, so I guess no, that's all for the basic and common statistical method.
Problem or the objectives of
Wait
your
lang.
study.
Okay, for the common and statistical tools. So have you heard of this before? Anyone? Have you taken up all of the statistical methods or statistics or tools before? Anyone who would like to share? Yes, Jessa or Jacqueline or Ivorine. Can you still remember how are these statistical methods done? Hello. So we still have 6 minutes now of our time. But if you don't have more questions or clarification regarding the topic, so please answer my question. Hello, are you there? Can you hear me? Lynn? Any of you? Or you can comment on the chat box, please. Yes, anyone would like to answer the question? Yes, Raymer. So I wanna know first kung nakadungog na ba mo ani sa inyong statistics? Kasi if not, then we will, discuss them further, no, para makuha na ko ang inyong background or knowledge of these statistical methods. So anyway, we don't have much time. Thank you for attending in this session. So next meeting, we are going to continue with the report and also with statistical, how to make this particular as mga like this percentage, mean, median, mode. So using the Excel. So we're going to do that as part of your training in making your proposal or in the future. So I guess yun lang muna, and thank you very much and hope to see you again next meeting. So if you have further questions and clarification, just chat me in our group chat. Okay, thank you and bye-bye.